Hello. In this video, I would like to talk about the percolation theory, and you can also learn how to implement your own connectivity node in Houdini. So we have a 2D pixels grid here, and for each pixel, I'm going to give it the probability for it to be open or closed. If it is open, well, I'm going to color it as white. So I set the probability to be open as 0.56 here, and let's change the seed. And the question for the percolation theory is, let's imagine we are pouring some water on the top. And the question is, can the water fall through the box and go to the bottom? So the white is where the water can flow through. So we see the water can flow through here like this, and it is blocked here. Yeah. So we created our custom connectivity node to see the connectivity color. Yeah, so we see the water will be blocked here. It's not connected from the top to the bottom. So let's change the seed here. And we can see that it's really difficult for the water to fall from the top to the bottom. No matter how hard I try to, in this example it is, but we can see that the probability is really low. And if we set this to 0.45, basically it's impossible, we can see. But the interesting part is if I set this to 0.62, we can see the water will basically must go through from the top to the bottom. So yeah, in science, people have plotted this map. The horizontal axis is just the open pixel probability, and the vertical axis is just whether the water will fall through from 0 to 1. And we see that there is a phase transition when the probability to be open is 0.593. So if I set the value to 0.594, basically we have a high chance for the water to fall from the top to the bottom. And this is what the percolation theory is studying. Yeah. And there are also a variation. What I'm implementing here is called the side percolation. So the water is flowing through this white block. But there is another variation, is the bond percolation. That is, for each bond, there is also a probability for it to be open or closed. So the question is the same, whether can we let the water to flow from the top to the bottom? So yeah, this is I implemented both here. This is the bond percolation, and this is the side percolation. For the bond, I simply use the method here is pretty simple. We use the Houdini built-in connectivity node. First, we create grid and convert it into line, and then we just, for each of the primitive, that is for each of this primitive, we we are just going to use a random, and to create an attribute called R&D and just remove based on a threshold, and use connectivity in Houdini to create connected pieces, and we can get this. Yeah. But for the side percolation, that is to say, we are not trying to create bond percolation, but side percolation. And in this example, I create my own data structure. That is, we are going to create our own connectivity node. And it's a technique algorithm called weighted quick union, but it will take some time to really explain it. But if you're interested, you can read these slides. They are very good and very clear about what is a quick union algorithm. Basically, what we are doing here is we can see that these are connected components. They are represented as trees. And we just use an array to store the parent of the tree node. So for the 2, we store 9, our parent. And if we are going to connect it to different pieces, let's say I wanted to connect this group to this group, then all I need to do is set the node of 6 to assign it to 9. So yeah, they are connected now. And if we're going to check if two components, if the 2 nodes are connected, all we have to do is travel upward to see if their roots, the tree roots are the same or not. And there are also some optimization technique is going to yeah, just read this, and there's some advanced algorithm called path compression, and yeah. And basically, this is just the same implementation. The code here is just the same implementation showing here. I will put the link in the description. So we can create our own connectivity nodes. Yeah. See you.